So today we're going to dive into something called expected utility theory. It's this really powerful framework that economists built to model how we should make the perfect choice when we don't know what's going to happen. But here's the fun part. As we're about to see, what's perfectly rational on paper, well, it isn't always how our very human brains actually work. Okay, let's get into it. I mean, really think about that for a second. Your entire life is just one big series of decisions made under uncertainty. From picking a major in college to just figuring out if you should bring an umbrella today, the outcomes are never, ever guaranteed. So the big question is, how can we build a logical model for that? How do we take all that messy, gut-feeling, human intuition and turn it into something like a science of decision-making?
All right, to build this whole theory up, we have to start at square one. We need to create a simple language to talk about our preferences. Before we can even touch on risk or probability, we first have to figure out a clear way to describe what it is we want in the first place.
Now, I know this looks super basic, but trust me, this is an incredibly powerful idea. Economists use this very precise notation to turn our feelings, our wants and desires into something formal, something logical. So if you'd much rather have an apple than a banana, that's called a strict preference. If either one is fine, you're indifferent. This simple, clear language is the absolute foundation for everything that's coming next.
So what does it actually mean to be rational in the world of economics? Well, here's the key thing. It's not about being smart or making the best choice. It's all about being consistent. For your preferences to be considered rational, they have to be complete, which just means for any two options, you can always say if you prefer one to the other or if you don't care. And second, they have to be transitive. This one's easy. If you like apples more than bananas and bananas more than cherries, you've got to like apples more than cherries. Simple, right? Your logic can't just go around in circles.
And this is where it gets really powerful. Once we have those consistent preferences, we can translate them into actual numbers using something called a utility function. Think of it like a way to assign a happiness score to everything you value. If you prefer apples to bananas, then your utility score for apples, let's call it U apple, just has to be a bigger number than U banana. This is what lets us start doing math with our desires. Okay, that's all well and good when we know exactly what we're getting. We can rank things, but what happens when the outcomes aren't certain anymore? What happens when we introduce risk, chance, and probability into the mix? This is where our nice, clean model starts to get really interesting, and it's also where we run into our first major puzzle.
All right, let's play a little game. This one was proposed centuries ago, and it still trips people up. The rules are simple. We flip a coin. If it's heads, the prize money doubles, and we flip again. The moment we get a tail, the game's over, and you win whatever's in the pot. So you could win $2 on the very first flip, or 4, or 8, or 16, and so on. So here's the question. How much would you be willing to pay me to play this game just once?
You ready for this? If you do the math and calculate the expected value of this game, the answer is infinity. Yeah, infinite dollars. That's because there's a 1 in 2 chance of winning $2, a 1 in 4 chance of winning $4, a 1 in 8 chance of winning $8, and it just keeps going. When you add all that up, it literally goes to infinity. And yet, I'm guessing you wouldn't pay more than, 10, maybe $20 to play? This puzzle shows a massive hole in this simple model. We don't value money itself. We value what that money can do for us.
And this is the brilliant solution that Daniel Bernoulli came up with. He realized that the value of a dollar isn't some fixed thing. Getting an extra $1,000 is life-changing if you're struggling, but a billionaire might not even notice it. It's not about the cold, hard cash. It's about the utility, the actual usefulness or happiness that those dollars bring to you.
Bernoulli's insight was a total game changer, and it laid the foundation for a complete theory of how we make choices under risk. Centuries later, a couple of guys named von Neumann and Morgenstern formalized it all. They built a complete framework for making rational decisions when you're facing the unknown. Now, to analyze risk like a scientist, we need a special tool. And in this theory, that tool is called a lottery. But don't just think about winning the Powerball. In this context, a lottery is any situation with uncertain outcomes. Choosing a career path, that's a lottery. Investing in the stock market, definitely a lottery. It's just a set of possible futures, each with a certain probability of happening. Okay, for this theory to really work, we have to assume that any rational decision maker follows a few basic rules, or axioms. The first one is easy. It's the same stuff we already covered. Your preferences are complete and transitive. The second, continuity, basically just says that there are no outcomes so good or so bad that break the math. But the third one, independence, is the most important and honestly the most controversial. It says that if you prefer a trip to Paris over a trip to Rome, then you should also prefer a 50-50 shot at Paris or winning a toaster over a 50-50 shot at Rome or winning that same toaster. The toaster is an irrelevant distraction, so it shouldn't flip your original preference. Now, keep that one in the back of your mind, because it's going to be a big deal later. And here it is, the centerpiece of the whole thing, the expected utility theorem. What it says is if you follow those logical axioms we just talked about, then your choices can be described with this beautiful, simple calculation. You will prefer one lottery over another if, and only if, its expected utility is higher. You just take the utility, the happiness score, of each possible outcome, multiply it by the probability of it happening, and add them all up. It's a recipe for making the most rational choice. So we've done it. We've built this elegant, beautiful theory for how a perfectly rational person should make choices under risk. But does it actually describe how we make choices, out here in the real world? Let's put it to the test with a really famous experiment. Okay, I want you to look at this first choice from a guy named Maurice Elias. You can pick choice A, which is a gamble with a really good chance of winning, but a tiny 1% chance of getting nothing. Or you can pick choice B, a guaranteed 100% certain $2,400. Now, when asked, the vast majority of people choose B. That certainty, that sure thing, is just too good to pass up. Okay, remember what you picked. Now let's look at a second problem. The odds have changed a bit. Now you're choosing between two long shots. In this case, a whole lot of the exact same people who picked the safe option before will suddenly switch their preference and choose C. They'll chase that slightly bigger prize of $2,500 because, hey, both probabilities feel pretty low anyway, so why not go for the bigger payout? And here is the punchline. If you chose B in the first problem and C in the second, you just contradicted yourself and violated that independence axiom we talked about. Look closely at the two problems. The second problem is just the first problem, but we've taken away a 66% chance of winning $2,400 from both sides and replaced it with nothing. That's the irrelevant alternative, the toaster. If you truly preferred the safety of B over the gamble of A, you should also prefer the relative safety of D over the gamble of C. By switching, your choice becomes inconsistent. What feels like just common sense is, according to this theory, totally irrational. So, what on earth does this all mean? It means that expected utility theory is an absolutely fantastic benchmark for pure rationality. It's a normative model. It gives us a blueprint for how an ideally logical and consistent person should behave. But it's not always a perfect descriptive model. It doesn't always predict how we, messy, real human beings with all of our weird psychological biases actually behave. And that leaves us with a really fascinating question to chew on. This theory gives us a perfect blueprint for making a logical choice, but we humans seem to consistently wander off that path. So if we aren't the perfectly rational actors that these economic models imagine us to be, then what are we? And what rules actually guide our decisions? But that is a question for another day.